आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
From microscopic crystals to colliding continents, Dr. Barun Mukherjee traces the geochemical breadcrumbs hidden in the Himalayan rocks to piece together how Earth's slow-motion collisions built the roof of the world.
Myself is Dr. Barun Mukherjee. I'm working here as scientist. My institute name is Wadia Institute of Himalayan Geology. It is a DST lab. And mostly we work in the manner that the whole 5-year project we divide into the activities, sometime in a group. So presently we are working as an activity, and our activity name is Activity 1A. There we see crustal evolution, particularly the geodynamic evolution of Himalaya, and by applying a lot of tools and technique. In my activity, we have 5 members in a different expertise. Each one has his own expertise, and everyone gives his best way to satisfy the objectives of this, to address largely on the crustal evolution of the Himalaya. And that the way we work, the way our activity members work, so that we can achieve some bigger objective or bigger goal of the Himalaya, particularly to the evolutions from pre-Himalaya to post-Himalaya. And then this if good result comes, we try to publish in a good journal. This is ultimately our goal, to give a good insights of the Himalaya. And obviously, whenever the government wants to reciprocate the way they want, actually, we try to give the answers also. Like in case of the mineralizations, in case of the other, like if anything for the landslides, so we also give kind of the lithology of the rock, and this the rock type, pattern. And of course, that basic objective we have to see that the pressure, temperature, and the time of the Himalayan evolution. That is the overall that we try to do it exactly. The past actually, that largely this is a major objective, that the crustal evolutions or Himalayan geodynamic evolution. And when that evolution terms come, then first picture come, then what way we have to say the evolution in terms of the pressure, in terms of the temperature and the time. And what happened during the formation of the Himalaya is that the Himalaya formed suddenly by the collision of the two plates, or something happened before that actually. So initially we much more focused, because when you say that geodynamic evolution, so we try to see that the rock that might have formed in the very higher depth, might have formed in the subsurface level, how they come up on the surface, and by which mechanism it come up, and by which process, and what it reciprocate what exactly. So that is the thing, and we focus directly focus on this the Ladakh area, because there we see the two plate connections between India and Asia, and of course in the lesser Himalaya, of course in the higher Himalaya, whatever the rock comes on the surface, we try to see that exactly. Ultimately see that many times these questions comes, and then what way we have to say. Ultimately, the fundamental research of the Himalaya is very much needed. Unless we know what is happening in the subsurface, it is very hard to say that what would be the effect on the climate, what would be the effect of the other. Because we know that Himalaya, it is a very dynamic Himalaya, means it is the most young Himalaya, and it is thrusted and faulted. But is that it is only the topography does matter, or it is also playing a lot of role inside below the crust actually. So therefore, this kind of the fundamental research is very important. Unless we know what is happening below the subsurface, what is happening below the deep earth, that whatever we try to figure out, this is sometime we feel that there could be a gap. So we try to see inside of this deeper earth. And obviously such type of the rocks we see, it is present all along the suture zone. Sometimes we see that suture zone. When I say that this is between India and Asia, this everyone knows that the Himalaya is the result of the collisions between the two plates. So therefore this type of the fundamental research is very, very important. Other than that, it is really not possible to address many things. Nowadays we see that a lot of mineralization questions are coming with the Himalaya. Yes, for the economic purpose, Himalaya is not very good host for that, because ultimately economic does matter, but Himalaya also occurs a lot of mineralizations. That part also we see that. When we talk for the geology, the first picture comes, it is maybe they can see that millions of years of history. So if I can see that the millions of years, Himalaya it's very young, it is a 50 million years back it formed. So, but how to say that this is the 50 million years? In geological terms, this 50 considered as one of the young Himalaya. So therefore it is called young mountain chain, starting from this whole 2,500 kilometer long Himalaya chain. It is quite a young. Even though in the present scenario, a lot of activity we see exactly. Obviously this is not my part, because a lot of activity, I mean to say, a lot of earthquake is happening. So people say it is a dynamic and things are still generating inside the surface. So that ought to reciprocate on this surface actually. So since this is young and since Himalaya is gaining height, so and of course it has a lot of geological processes like weathering, like erosion. So it is compensate anyway, but still it gaining the height. So therefore it is always means Himalaya considered as one of the hotspots for the all geologic fraternity of the all over the world. Only thing that's the Himalaya gives kind of a copybook type of signatures. You ask for any geological feature, you will have there exactly. Okay. So this is very important. Because as far as my best of knowledge, I could see that Himalaya is a kind of place where the all best geological institute from the whole world is working. So this is one of the very important geological feature that we are fortunate this way, that whenever we feel to go to the Himalaya, we can easily approach. So therefore we are giving our best to study the Himalaya. Okay. Unless we know the fundamentals of the Himalaya. So this is very hard to connect with this, what is happening in the recent scenario. Like even just one example, if I say that the landslide is happening everywhere, exactly. So unless we know that what type of the rock they are that rock at the very friable, are that rock are very hard, are that rock really suffered some millions of years of the weathering or erosion? So therefore this is all ultimately that we have to say that what is the basic of these rocks, what is happening in that area, from which depth it comes exactly, whether it is acidic, whether it is a igneous rock, metamorphic rock, or the sedimentary rock, because we know that the strength of the rock depends upon the pressure, temperature, and the time. So this is very important ultimately, because anyway directly, indirectly it is effect on this local masses. So that's very important, because nowadays everywhere we are making tunnel, everywhere we are making landslides. We see that landslides, the earthquake. So this kind of the crustal evolution or geodynamic evolution is very, very important to see that the rock present on the surface, what they are exactly. So therefore this, because we see a lot of things, like solid part we see, liquid part we see, and the volatile. All the three factors are very important exactly. Volatile I mean to say because every rock has its own volatile phases that may not appear by the naked eye, but we see through the microscope. They play the greater role exactly. When we make a big contribution in the big journal, then world usually see that, and then ultimately that this kind of the research gets a lot of citations, get a lot of reading. That only thing is depend that where we are publishing exactly. So at the present we see that means kind of the research we are pursuing here, it is no way less than any of the country exactly. So absolutely, and then the many other things that how much, because it is the era of the technology. how much we are putting the money, how much we are purchasing the big instrument. Because that days are gone, then initially we go for this like centimeter scale analysis. Now it is a nanomicron scale analysis. We can put the more money, you can put the more technology, the things will come like that. So the best of our, whatever the kind of the means, the facility we have, we try to produce as much as possible. And that is that at least we can say that, yes, we don't say that we already done everything exactly, but we are trying our level best to match with their research. Not exactly to match their research, means that research is worthful, so that we can give the answer to the government also sometime. So we see that a lot of like you can say that like ONGC, they are approaching us actually. That means, of course, they do not know much about this Himalaya now, and they approach means the kind of the research we do, what way they can take our help exactly. So time to time they contact us actually, and then we go and we do kind of a meeting with them exactly, and they frame accordingly. And many times we see that in here there's a board of members, many of the geologists they call how to improve their kind of a production or all. So it does matter. And then ONGC, and sometimes I see nowadays is a lot of NGT program, National Green Tribune, continuously they are contacting us to give the best information. And many industries, like even the small sector industry, they are also approaching us exactly. Like NTPC, they are also approaching us. So we are helping them, and then we are giving our best to satisfy them exactly. Currently, this particular activity, we produce paper in the geology, which is one of the high rated journals, and of course we publish paper in the chemical geology, even the International Journal of Sciences, like our colleague, they are producing paper, geological journals. So I'm not taking the name of the national journal, but internationally those are, means the journal doesn't require any kind of introductions. It is just you have to take the name, people understand. Even the Society London we are publishing. So this particular, yes, I have to say about my activity 1A. This activity 1A, I see that all the members are very, very potential, and they have their own specialized. It is not kind of the overlap science we are doing exactly. Everyone has its own expertise, and they are producing accordingly. Okay. One part that really scientists always very hesitant to say, because rather than if you could ask me, do you really carry any kind of the visiting card? I'm very sorry to say that we don't carry any visiting card, because I do not know even sometimes what happens when people ask for give some media bite, and we always hesitate to give actually media bite. I could see that the scientists are a little bit of the conservative this way exactly. They do not want to pamper their own work. Whatever we are trying hard, that is we are giving. And I don't really remember about, but in the very early career, I received one appreciation letter from the Ministry of Science for discovery of the one mineral. And after that, that mineral changed a lot of Himalayan dynamics exactly. Right, it's okay. I mean to say that means we are not something very that some award has to be given. It is okay. Sometimes it is fine. Absolutely. I think that we want to say that kind of research we are pursuing, and then we appeal through this media that more student could come, more study can be, because Himalaya is a huge exactly, and then nowadays a lot of proxies needed to be implemented actually. So a lot of student, we are appealing that a lot of student we want exactly to do the research. Those student now are moving toward the more softwares and this, but ultimately this is the kind of the research. It is required for the national building, and we cannot assure all the time whosoever the student comes they will get job, but sooner or later this kind of the institute or government, they provides job exactly. But ultimately it's a big country that students should come forward. They can make their presence, they can put their food, then only it is very nice. And I'm very thankful to DS for initiative taken by the DST for this popularizations of the science and what really I understand, because I have seen that ultimately the question comes what we are giving to the mass, and this is I think one of the first very good initiative by the DST. So they are taking our science to the masses. That sometimes we feel that we fail to do that actually. So DST are doing the same for us exactly. It is a great honor, and it's really I'm thankful to. Thank you. Thank you.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.